Hello again, my name is this, and I'm here to talk to you on all these technical things which we use to make computer games. Our topic for today is models. No, not that kind of model. I mean 3D graphics models. Excuse me, folks. It seems we have a technical problem which needs to be fixed. I'll be right back. That's better. Now, where was I? Models. The game is basically lots of 3D models. Moving around, shooting each other, talking to each other, completing quests, whatever. Models are also used to make scenery, but you already knew that, didn't you? A few games create their models using code, but most of it is done by artists and 3D modelers. So let's talk about model creation. In the games industry, the main two softwares used are 3D Studio Max and Maya. These are commercial software and cost several $1,000s. If you want a job in the industry, you'll need to learn to use one or other of these tools. However, if you're doing this as just a hobby, or if you're running on a low budget, there are lots of other alternatives, low cost, free, and open source. Find something you can work with. Since I'm the technical guy, I'll not be explaining how to make models. But the game development team needs to work together. Content needs to come from the modeling side to the programmers and into the game. So we do need to keep a few things in mind to avoid problems coming up. Size. Size is vitally important. So modelers, make sure all your models are of a consistent scale. Programmers hate it when each model must be scaled to a different size in order to fit into the game. Same thing also applies to aligning your model to the axis. You don't want your model levitating off the ground or running backwards, do you? Watch the polygon count. People who make videos want their models to be really realistic, so they have a very high polygon count. However, within a game, we have a polygon budget which modelers will need to keep within. I had a student once who went out to the internet and found this million polygon model, downloaded it, and then tried to import it into their game. Then they come to me and ask, why is the game hanging? Another thing which you have to standardize is the interchange format. More on that later. Let's move on to our second topic. What is in a 3D model? Though there are hundreds of different 3D modeling software and hundreds of different model formats to deal with, generally all the models will be roughly the same thing. They have vertices, indexes, textures and or colors, plus probably some animation data. There are a few other items which might be there, but these are the main bits. So let's look at these. A vertex is a 3D point in space. Normally when you're modeling, you're really interested in the polygons, not individual vertices. But as you can see, a polygon is just a collection of vertices linked together. When the computer stores the polygon, it actually stores it as a set of indexes, normally 3 indexes to make up a single triangle. Since vertices are shared between many different polygons, it's a lot more efficient just to store the indices for the polygons rather than storing the same vertex multiple times. Colors are really simple. I don't need to go through this bit. If you watched my video on lights, thank you, you may remember about that shininess attribute that you need to watch out for. But other than that, nothing to it. For texture, it's not just which texture to use. That's art. I don't do art. But it's also which bit of the texture is attached to which part of the model. In the modeling software, you just drag various chunks of the texture onto the model. Or is it the other way around? I'm not very sure. Anyway, internally, what is happening is that each vertex will also have a U and a V coordinate which specifies which bit of the texture will be mapped to that vertex. These are important in the code as we need that information to position the texture in just the right place when we get to display. Animation is where things start getting rather complex. The first generation of 3D computer games didn't have animation at all. As such, most of them were based on spaceships or cars or other inanimate objects. But these games were still cool. Then people started adding models which could move. They would have a walk cycle, a run cycle, or some kind of action cycle. The problem is that the model could only perform one animation at a time. So you would see a player in the game stop walking, enter a stationary position for half a second, and then begin the next action, say jumping. More recently, animations are now being blended together to make the transition more natural and less rigid. Also, if you look at any of the recent shooters, you will notice that the upper and lower body is animated independently. The legs move when the player presses the keys, but the arms move in response to the direction that the player is aiming and firing. The animator is usually responsible for the individual animations, but it's the programmer that needs to provide the code to blend all these movements together. And we haven't even touched the advanced topics, like ragdoll effects when the model's animation is controlled by the physics engine, or facial animation, or adjusting the model's leg placement so that they stand on the ground rather than hover or glide over the ground looking like some kid's cartoon. Of course, if we want all these nice effects, it's going to take a lot of effort by the modeler and a lot of code from the programmer. Let's move on to our third topic, the model pipeline. This is not about oil or anything like that. It's about the steps which need to be taken to get the model from the artist to the game. In an ideal world, the game engine and the modeling program would use exactly the same format. In practice, it never works that way, mainly because the modeling program and the game engine have totally different needs. So the game engine may well ignore a large chunk of the information, but instead need extra stuff. Generally, it ends up with the modeling program having its own format for its work, and then it will export in some standard format which the game engine can use. This standard format is known as the interchange format, which begs the question, what is the standard? Cynics and those people who have worked in the industry will tell you that there is no standard. There is no one perfect solution. But you probably knew that already. So you need to look at what is most suitable for your needs. There are a lot of different formats out there, some proprietary, some general purpose. Modeling programs are usually fairly flexible devices and can export to a variety of formats. They often have a way to build plugins which allow people to write new exporters for new file formats. Game engines, on the other hand, are not so flexible, but it also depends on the engine. For example, the open source engine Erlicht can export about 20 different formats. At the other extreme, engines like, say, Unreal only support two formats, an animated format and a static format. And both of these are proprietary Unreal formats. But at least Unreal provides the plugins so you can export in that format, so it's not too difficult. Up until DirectX 9, there was a DirectX format, known as .x, but Microsoft, in its infinite wisdom, decided to throw away the format because everybody ends up writing their own format anyway. Yes, this might be true of the big AAA studios, but it's not true of those people who are teaching or trying to learn the topic. Therefore, we have to use some new format known as SDK Mesh, which is not well supported by any of the modeling packages. So it's rather complex right now. A few of the more common formats you might want to be aware of are X, OBJ, and FBX. .x is the DirectX format. At least it was until they threw it away after DX9. But a lot of tools and engines still use this format. OBJ is an ancient format. It was used in the mid-90s for various 3D drawing packages. It's old, but it's really easy to read. See? And it's been used as a common data interchange format. FBX seems to be the new upcoming standard for 3D data exchange. A lot of modelers and game engines support it. It's a fully featured format with lots of stuff you can do with it. Unfortunately, all these features mean that it's also hard work to build a model loader for it. Having said that, it's probably one of the best formats available today. So, We know we need a format, and we've looked at a few. Which to use? That's easy. Look for what your modeling program can export and what the game engine can import. Find a match. Ideally, the less steps the better. The less plugins and conversion tools you have to use, the less likely you are to have important parts of your model's anatomy scattered around the world when the conversion routine fouls up. And don't get me started on the problems that you can have with exporting and importing animations into games. Having a complex conversion progress is not only tedious, but if there's a problem, you're going to have to check every stage to try and figure out where it went wrong. And it's going to hurt. If you're building your own game engine, then look for what features you need in a model format and then find the simplest format which matches those needs. My DirectX 9 engine looks like this, and the DX10 version looks like this, mainly because these are the file formats which it was easy for DirectX to load. It would have been nice to load an FBX directly, but the code to do this is just too complex. So, in conclusion, there are an awful lot of models, an awful lot of tools to make models, and an awful lot of model formats. None of that really matters, as all you want to do is get your model from the art team into your game as quickly and as painlessly as possible. So figure out which tools and which formats to use, run a few tests with simple models just to make sure it works properly before you expend large amounts of effort in building up all your art assets. The model might just be a big collection of polygons and textures, but it looks real ugly if it gets turned inside out when you put it into your game. Until next time, happy coding!